Hello everyone. In this problem, we are going to find the moment of force F about point B. The moment equation tells us that the moment is R cross F. And as we discussed, R cross F is not the same as F cross R. So we need two vectors, the position vector R and the force F. The force F is given to us in Cartesian form, so we don't need to do any further manipulation of the force F. R is the position vector from point B to point C here. So that would be our position vector, or BC, because we are finding the moment about point B. So we start from point B and going to our vector, which is acting at point C. So I need to find the position vector RBC. And for moment, I only need the position vector, not the unit vector. From B to C, that would be 0.7 J, here 0.4, 0.3, 0.7 J, and I'm going down 0.3 negative Z, and the extraction would be 0. So I have my two vectors, I find the moment. So moment, the first row would be I, J, K. The second row would be my first vector, which is R. Be 0 for the I component, but for the J component is 0.7 and would be negative 0.3. And the third row would be the second vector, force F, 600, 800, negative 500. So I write it here, 600, 800, negative 500. And I find it here, force M, I remove the first row and the first column. That would be 0.7 times negative 500 minus negative 0.3 times 800. So that would be 0.7 times negative 500 minus negative 0.3 times 800. That's the I component. And the J component comes with a negative. Again, that negative is part of the definition of J component. I remove the second column and the first row. That would be 0 times negative 500, which would be 0 minus negative 0.3 times 600. So that would be positive. But I write it at negative 0.3, so you know what I did here. And the last component would be K. For K, I remove the third row, the third column, and the first row. So 0 times 800 minus 0.7 times 600. So if I simplify that, the moment about B is a vector with negative 110 I, negative 180 J, negative 420 K. And the unit is Newton meter.